In chemical engineering, we love large scale processes, but what would it be without hidden heroes? Are you having complications when operating the plant? Or perhaps struggling to identify equipment? Maybe you cannot prove safe operating conditions. The hidden heroes prevent this from happening. The solution is piping and instrumentation diagrams. Piping and instrumentation diagrams are technical drawings that help operators to carry out a controlled and safe operation. They exist for all different processes in the industry. So what do P&IDs do? They identify and describe the role of equipment such as valves, pumps, and compressors. They can be updated or modified. They show all interconnecting pipelines and help design a process. Be aware that P&IDs are not the same as process flow diagrams. One of the key differences is that P&IDs do not include temperature, pressure, and flow data. Earlier, we mentioned hidden heroes, but what exactly are they? Here's a hint. They've already appeared in the video. Chemical engineers usually talk about reactors, heat exchangers. However, valves, pumps, and compressors are left behind. These are our hidden heroes, the constituents of the P&IDs. Since it is in their nature to be well hidden, we need aid to help identify them. These two diagrams contain some of the symbols used to identify them. Take a note of the pinpointed symbols. Reciprocating compressor, lift check valve, butterfly valve, and the inline centrifugal pump are the hidden heroes we are going to go into detail about. It is important to understand that there are many others such as the gate, globe, and plug valves, as well as pumps and compressors. The lift check or non-return valve. The non-return valve operates on a spring basis and the use of the pressure exerted by the water. The valve is assembled by firstly adding the spring and a circular piece into the bottom half of the valve, then adding the top half and screwing it in. As we can see, the water enters through here, and when with enough pressure, it will force the spring upwards, allowing the water to flow in the forward direction. The water cannot flow in the other direction, as the spring part would block off the passage. The inline centrifugal pump. This is the inline centrifugal pump when in pieces. Firstly, the shaft is fitted into the motor where the rotary force is generated. Then the plate is fitted at the end after a few other necessary parts. And finally, the housing for the plate, which also shall guide the water flow. However, some of the main industries they are used in are the food, beverages, pharmaceuticals, and light chemical industries. The butterfly valve. The butterfly valve is a compact and light valve. It has a quick on and off system with quarter rotational turn. This valve has a low pressure drop and a high pressure recovery. It is used mainly in slurry services, cooling water, and fire protection. A reciprocating pump has a low capital and maintenance cost, as well as a continuous flow accompanied by high power and pressure. These compressors also vary in application depending on the size and type. The applications range from oil and gas to air separation to the food and beverages industry. In conclusion, these hidden heroes help us as chemical engineers to perform our jobs to the best we can. Despite always being in the shadows, we know they are our heroes. Until next time, and good luck spotting the hidden heroes, although perhaps next time you won't have trouble at all.